This is my CNIT 176 computer architecture project with a Raspberry Pi. In this, I constructed a Pi hole and a VPN. Mark McConnell. So what are we actually accomplishing here? So in this project, we'll be turning a common Raspberry Pi into a functioning network-wide ad blocker, as well as a VPN that we can connect into from external. This blocks unsafe traffic and unwanted ads, and also gives me an external access to my servers. Now, why would we want to do this with a Raspberry Pi? The Raspberry Pi is ideal for a project like this. Its small form factor combines with an impressive array of I/O options to create a remarkably capable device. I have mine in a case here with a fan to keep it cooled. I chose to use the command line only version of the operating system to conserve resources. After all, Pis running Linux are perfect for SSH access, allowing complete configuration remotely. My particular model is the 8 gig Raspberry Pi 4B, which includes 2 HDMI ports, 4 USB ports, an audio jack, and more. However, for this project, I only needed the gigabit Ethernet port and power connection to start to finish. The Pi's high-speed network interface made SSH not just feasible, but actually preferable, both for performance and cable management. I was able to do everything, all the installation, and all of the program configuration over SSH, and so I really only needed just this port to run all the data, and this port to power it. Additionally, the Raspberry Pi's ARM CPU architecture deserves special mention here. Its power efficiency makes it far superior to a bulky, power-hungry PC for lightweight tasks like DNS blocking and VPN hosting. We aren't doing anything super crazy on the Pi, so even though I have an 8 gig, we won't be using all of its resources. Having something small and low-powered is very ideal for this, which is where the Pi really shines. Additionally, being able to run Linux is very crucial to this. By running the Debian-based Raspberry Pi OS, Raspbian, this project was made incredibly smooth due to how efficient it is. The download install for this operating system is very, very lightweight. Additionally, being able to install the operating system on SD cards, flashing new operating systems is very easy. So during troubleshooting, whenever I need to do a reinstall, this comes in very handy. With the Raspberry Pi being super lightweight and super reliable, I can truly set and forget it once I've installed all my programs. So here are the components all laid out. This is how they are when they're all connected together. So we'll be ignoring this computer for the most part because this is a server that I run aside from this project. However, the Pi will be assisting with this because it will be operating as a VPN, which will let me connect into my network and manage this server, which will be pretty cool. So this will also be acting as a DNS server for this router right here, which is an Asus RT-N16. It supports gigabit Ethernet and 2.4 gigabit Wi-Fi, or gigahertz Wi-Fi. Now this right here is a cable running down to my laptop, which I'll be using to access all of these devices. And this cable goes up to the WAN port, which is actually just Purdue's network. Now here's a logical diagram of my LAN, which we just saw. So this is the RT-N16 router, which has the IP address 192.168.1.1, which connects to my laptop, assigning it the address 192.168.1.69, and the Raspberry Pi 192.168.1.42. Now, this WAN has a question mark because for most projects, you would be able to just forward your port through the router here to the wide area network and be able to access the VPN. However, this is what we actually face in my situation. So here's my LAN zoomed out, and we can see a problem arises. This is the same network, but I've replaced the WAN question mark with Purdue's network because I am operating in a subnet of Purdue's network since I live in the dorms. So we need to cross this barrier, but since I'm not the admin of Purdue IT, we can't do that through this. We'll have to find an alternative method. Alright, so we're going to start by installing the Raspberry Pi OS. Choose our Raspberry Pi, it's Pi 4, and I'm going to be going with the light 64-bit since we only need the command line interface. Select a drive. Now I'm going to edit these settings. I've already configured them. Basically, the gist of it is we're going to enable SSH and make sure we have a username and password set. So I'm going to leave that as where they are, and then we would just install it from there. Alright, so here we are in my router settings, and the key things we're going to set are within our LAN is our DHCP. We're going to be setting a static IP address for the Pi. So you can do this by choosing a MAC address for your Pi, just reading off of the Pi and setting a static IP. Here is mine. And then also, once you've completed installing the Pi-hole, you're going to set a DNS server over in the WAN area, internet connection. You're going to set the DNS server 1, the primary DNS server, to be that Pi's IP address, so that it can direct to it too. I've also set a secondary one, just in case my Pi ever goes down, that way I don't lose internet connection. This is AirVPN, the service I use to connect the Pi to. So this is the client area, and to do this we'll go to VPN devices, and I've already made one, but I'll show an example. We will create a new device, and we will title it Pi VPN, and it is created. We'll go back to the client area, and we will forward a port. So it just creates a random one for us, and say we were connecting to 518.2.0, which is for WireGuard, and we can set a DNS, dynamic DNS name for it as well. So we'll just set a random one for now. Additionally, we'll want to set configuration files so that we can connect to it, and we'll just go through the this right here to select for Raspberry Pi and open VPN and whatever server we want. This is what we will be using to connect the Raspberry Pi to AirVPN. Alright, I'm here at the Pi. I'm going to paste in this command which will install the Pi-hole for us. Alright, so we're going to just go through this menu, and we will be using the static IP address that we have. We'll be using Ethernet 0 as our interface, Cloudflare as our DNS server, and we'll be using the default blacklist. Yes, continue, and that's it. Pi-hole is installed. Now it's reachable right here at this address using this password, and I'm going to go over and show you guys how you can manage that. Here we are back on the Pi. So I'm going to paste in this command, which is going to let us install the Pi VPN software. Now this one does like to take a while to load, so I will be doing some jump cuts to save time. And here we are. This is the familiar menu, just like the Pi-hole. So we're going to go through this. We are going to select No for force IPv6. We are going to select Yes for using DHCP because in the router we set a static IP address. Set the current user, and we will be using WireGuard. So this is the default port for WireGuard. Remember this because we're going to have to forward this later through several programs. And now it's giving us the option, since the Pi-hole is already installed, we can use that as the DNS server. We're going to select Yes. And we are going to select this. We are actually going to change it later on. Yes. Alright, now that's about it. It's going to ask us to reboot the Pi, and once it's rebooted, it will be all ready to go. Here we are. Yes. So here we are in the Pi-hole dashboard. We can see all of the options, and we're going to run a test to see that it actually works. So here's a website which has advertisements on it. You can see when we refresh it, they're still there. I'm going to enable the blocking. I've had it disabled so I can show you how it works. We'll jump forward, and when we refresh, we can see that there are no advertisements, just as there should be. The query is blocked or rising, and ads are getting blocked. And here we can see the rest of the dashboard. It shows us all the sort of statistics on how many ads we're blocking, where the traffic's coming from, and what stuff is getting blocked. Very useful. So here we are on the Pi side of using the VPN. So I'll just SSH into the user. This is just SSHing on the local area network. Now here I'll just print out what I have in my VPN file. This is just the command I use to connect to my VPN, AirVPN through OpenVPN. We'll activate that. And since the Pi VPN starts automatically, it's already connected, and we'll just start a TCP dump. So this will print out everything that the Pi is receiving through the port 51820, which is the VPN port. You can see right here, it shoots up right when the phone connects. I'll show you the phone POV next. So here we can see the phone POV of connecting to WireGuard. I'll activate the user after I've transferred the config file over. And now I can type in ifconfig to reveal my IP address, and I'll ping the router, which in this case is the Raspberry Pi. During the execution of this Pi project, I encountered numerous problems, and my troubleshooting process for each of them was mostly detecting network errors. So the first problem I encountered was that the Pi VPN was unreachable through outside of Purdue. Now, I knew this was going to be a problem going in because of my operating on a subnet, and the solution I found was to forward VPN through an external VPN. Well, I used AirVPN in this case, and which ended up being a very good solution, however not without its own problems. Here they are. So the biggest problem I encountered with AirVPN was that the ports were not communicating. Now, this was a big issue of AirVPN talking with Pi VPN, because AirVPN would forward port 51820, which is what WireGuard listens to on Pi VPN, and for some reason or another, Pi VPN would not accept just straight listening through AirVPN. I did test with other programs like SSH and FTP, SFTP, and Telnet, and they all worked flawlessly over just direct port forwarding. But for one reason or another, WireGuard was very angry with it, and the solution I came to was forwarding a separate port, which is 24402, and using the program SOCAT to translate it into 51820, which WireGuard would then listen to. This worked almost instantly the second I tried it. I'm not sure why, but it was a huge help to when I found the documentation for this. So the next problem I encountered was the WireGuard conflicts I was having. So WireGuard would get angry with me whenever I would connect to AirVPN. Now this is on the Pi VPN side, and I realized that this was due to two instances of WireGuard operating at the same time. So what I did to solve this was to force AirVPN to connect via OpenVPN, because I preferred WireGuard's configuration files to connect with my phone. So aside from this, I encountered a few other small issues, but these were the huge ones that I had to spend a few weeks troubleshooting. Now here are the lessons I learned from doing this project. Number one, persistence pays off. I worked very hard on some of these problems, and in the end, I found a solution to them. Additionally, tool mastery in TCP dump and SOCAT. There are some other tools too, but these ones I'd never heard of before this project, and now I think I'm going to use them in the future. A problem-solving and troubleshooting mindset. This really ties in with persistence, but I've really gained a lot of troubleshooting skills by going through this project. Additionally, network tools for the future applications. As I showed in earlier slides, I have a server that I run in my room, and this will definitely be assisting with that because these are some tools that I can use in my own personal projects and hopefully in the future with my career. I learned a lot from this project. It was really fun.